or your quiz will be Friday over 3-2 and 3-3. Thankfully, they do build on each other some. So any questions about what's expected of that? You do need to start 3-4 for Friday. That one is a longer section because it's kind of two main ideas in it. It's basically the question we haven't answered yet. We keep finding relative max and mins. How do you find the biggest value and the smallest value and ignore is it relative or not? So if you want just the biggest number and the smallest number, there's actually an easier way to do that. So that's the first thing we talk about, 3-4. And then the sad thing is there's two parts to the section. Second part is now word problems. Now you know how to find the biggest. Let's go maximize something we care about, like profit or minimizing a cost or something. So we'll spend roughly a week on that actually. So it slows down, but that's what we're going with. And then the exam is next Friday. So Wednesday we'll kind of have a review, finish up with the last quiz, and then the exam will be on Friday. But that quiz will be just one section. All right. I definitely recommend putting in time over the weekend because of the. All right. Any other questions or anything on expectations? Chapter 4 will be a nice change of direction. Because like chapter 3 is now that we know derivatives, let's do everything with them and solve all problems. And then chapter 4 we'll start a new concept, so it kind of goes back to the basics for a bit, for building up something new. Chapter 3 really is the applications and the most involved content probably. All right. So, any quick questions or anything? All right, so I want to graph the worst possible problem that we haven't tried to graph. It doesn't look too bad, but let's graph f of x equal to the square root of x squared minus 1 divided by x squared plus 1. Anybody know what this graph looks like? Technically, this is not something you could do in pre-calc. And it's because of that square root. If we didn't have the square root, this is technically rational and you can do it from pre-calc. But square root changes some things. So a lot of what happens in calculus, this is why chapter 3 is kind of different. In pre-cal, you deal with just exponential, just logarithmic, just trig, just rational, and you never overlap the ideas. Then you come in here and we say, here's a function that doesn't fit any of those categories, let's work with it. Or like we multiply everything by e of the x, and in terms of calculus, we can still do everything. Not necessarily what you're used to. So this is one we really don't know how to graph with only pre-cal. So we'll spend most of the day on this one example. How do we draw the graph? Remember, go back to the handouts for 3-2. It was two files. There's technically another file listed in the chart. That's because I forgot to delete it. I got a notification that y'all were clicking on it. If you clicked on it, it said error and went nowhere. So now you can't click on it because it's gone. What happens is that chart I used to post notes after class because we would do things on the iPad. So then I'd post the record of that after class. Sometimes those links survive, but the files did not. So sorry about that. So if you go to the chart, the handout, so it has the notes with the videos like we typically have, but then there's another like 2 or 3 page document on all these steps that you can do to think about for how f prime, f double prime relate to each other. That is really content you want to think about and learn about. Okay? It's overwhelming, but that really explains every concept now that we have 3 things we look at. Then it talks about how to draw the graph and what all the steps you can go through are. If you want just a set of steps, this is what you would do. you can watch that last video that probably lasts way too long. It tells to do 7-minute videos, or not above 7 minutes. This example is more than 7 minutes. Alright, so what do we do? What's the first step? Anybody do that? Yeah?
Find the zeros and where it's undefined.
Zeros and undefined, yes. So if we want to draw a number line for f, this is the thing. You move these all in a bunch of different orders. First, we'll just look at f. When is it positive, negative? So what do you need for that? You said you need to know when it's 0 or undefined. I always like to do the undefined part first, under the guise of call it the domain. Alright, before I really ever do a whole lot with a function, I always like to know its domain. What would be the domain for this?
X squared plus 1 can't equal 0.
Yeah, x squared plus 1 can't equal 0 because I can't divide by 0. So x squared can't equal -1. Is that okay? Does x squared ever equal -1? No, so we're good here. So this one gives no restriction. No matter what, x squared is not going to be -1. Is that the only issue for the domain? Yeah.
X squared minus 1 must be greater than or equal to 0.
This is actually the hard one. Why do I need this? You can't take the square root of the negative. That's the one that's harder or easier than this. I can't take the square root of the negative, so I need this. How do you solve this inequality? We have way too many options, which means this is now an impossible question. If you're in pre-cal, you do a sign chart. If you want to know really what this is asking, when is this positive or negative? You could do a number line for this expression and figure out when it's positive or negative. Treat it like anything else in this class. Or there's another one. This is the one people usually mess up. You could say x squared is greater than or equal to 1. Can I just take the square root of both sides?
As long as it's positive, right?
Can. But you have to be careful. What is the square root of x squared?
Plus or minus x.
Technically, no. If you're solving, so this is why I probably shouldn't write this at all. If I was solving x squared equal to 1, I would say x is equal to plus minus square root of 1. Right? But when we say f of x is square root of x, they'll say that. You only take the positive root. You never take the negative root. When you say take the square root of something, you always mean the positive root. So then how does that match with what we have here? If I want the positive root, how do I ensure I get the positive root when I do the square root? Yeah.
The absolute value of the square root?
This is one that is the easiest thing to forget that leads to issues if you go this route. If I say the square root of this is greater than or equal to 1, I mean the absolute value of x. Because what happens if you just write x? X might have been negative. If x is negative, could that have been a square root? Or that's not what we mean when we say take the square root, right? So I need this to be a positive number. How do you do that? Put an absolute value on it. Then what solves this inequality? That means x must be greater than or equal to 1, or x less than or equal to -1. Would that work for everybody? Think about something like 2. If I put 2 in here, 2 is bigger than 1, that makes sense. Picking a number bigger than 1, right? But I could also pick something really negative. If I take a really negative number, take the square root, now that's bigger than 1. This is more the standard way to do this. Technically, I need this, right? If I was gonna solve this inequality, I could just factor the left side. So what would be my solutions? You can draw a number line to think about it. And I have this expression, and what are the numbers that matter? Negative 1 and 1. If I plug those in, I get 0. What happens if I do a test value over here? If I take a number bigger than 1, subtract 1, it's still bigger than 1, or it's still positive. So I get a positive times a positive. This side's positive. If I do really negative, it'd be negative times negative. I think this is written in the videos this way sometimes. Positive, multiply the two together, stays negative. So you can do this with test values also. Like you can do sign charts, you can do test values, you can do number lines, you can do some combination of how to do those. Or technically, you can actually solve the inequality directly. There are lots of ways to do this. The problem is you actually have lots of skills now. Anytime you have lots of ways to do something, it makes it infinitely harder. Then you can't decide what to do, or you mix up the two. Alright, so that was what seemed like a long tangent. What's my domain? I got no restrictions here. Over here, if I want to be greater or equal to 0, I need to be over here or over there. X has to be less than negative 1 or bigger than 1. So all of this is to say my domain is negative infinity to negative 1, union 1 to infinity. There's really a lot of work just to say this is my domain. So you mentioned you want to do a number line for f. You want to know when is f positive or negative. So we need to know when is f 0 and when is f undefined. What this says is f is undefined from negative 1 to 1. Because what's the domain? The domain are the numbers you can plug in to be defined. Alright, so we technically know where f is undefined. It's undefined from negative 1 to 1. If you know the domain, you also know when f is undefined. That's another way to say it. The reason I like to do domain, though, when I draw number lines for f prime, what number line should I draw for f prime? The number line should always correspond to my domain f. This is the one that I keep using. So you'll see that as you go. Alright, so f equals 0. What would it mean for this to give me 0? Yeah, I would need the top equal to 0. So square root of x squared minus 1 equal to 0. So x squared is equal to 1, so x is equal to what? Now it is plus or minus 1. If you want to use our new cool technique, take the square root of both sides. Absolute value is equal to 1. Or absolute value of x. Which is another way to say x is plus or minus 1. Why do you do plus or minus? We're used to just thinking if you square negative, it's 1. But you do the square root, it's the same as doing what we did here. As long as you get the absolute value, it's all the same idea. Without absolute value, it breaks down. Alright, so when is f equal to 0? Only when I plug in plus or minus 1. So now I can draw a number line. My number line says I should do this. When I draw a number line, it should be representative of my domain. If we're going to graph, we want to draw a graph over our domain. But I want to know when is f prime positive or negative, when is f double prime positive or negative, when is f positive or negative. I'm ignoring all these values. If they don't make sense, I can't plug them in. You could just draw like this or something. It's weird to have just two separate pieces, but when we actually graph this, it'll have a piece on the left and a piece on the right. based on the domain. Alright, so if I plug in -1 or 1, I get 0. That's what we found. Now what do I do? I was trying to decide when is this positive or negative, right? How many test values do I need? I need to do a test value on this interval, and a test value on this interval. And again, nothing here matters. We're ignoring everything between -1 and 1, because none of that makes sense. F is undefined there. So let's say I do something like f of -2. What was that figure? Get square root of -2 squared minus 1 divided by -2 squared plus 1. So square root of 3 over 5. Is that positive or negative? Positive. All I care about is the fact that it's positive. Also need a number bigger than 1, right? So f of 2 looks pretty much the same. I need a positive number. They actually get the same number. Why is it the same number?
Because you're squaring it.
Yeah, I'm always squaring x, so do I even really care about the negative sign? If I do all the work on the right, I already know the answer on the left. That's convenient. Alright, so we have a number line for f. That's like a third of the way there, right? Now what? Need another derivative? So I need to find the derivative of x squared plus 1 to the 1/2 divided by x squared minus 1. Divided by x squared plus 1. So this would be what? Bottom times root of the top. Minus the top. Times root of the bottom. Divided by the bottom function squared. So x times x squared plus 1 times this minus 2x so x squared minus 1 to the 1/2 divided by our base. I know what to do now. I think this example would be the absolute worst example you ever do in life. Other than that one homework problem you asked me about what. Now you're going to get a trig function and be like, thank you. Nope. Never going to cross that hurdle. There's a great way to simplify this. So if I wanted to set this equal to 0 or undefined, there's something that makes it hard. One, it looks like there's a lot going on. How do you simplify this? Yeah. Well, I was just going to say, there's this issue with this negative x. Did I make a mistake?
I was gonna say, couldn't you split it into two fractions?
That actually won't be as helpful.
Oh.
Because usually if you get one fraction, it's easier to say top is 0, bottom is 0. If you have two fractions, this one being 0, that'll tell you about this one over here. So it's usually easier to have it combined. And this one actually simplifies nicely, it just doesn't look like it right now. And the reason is this negative exponent. This is technically a division here, but it doesn't look like it, right? If you want to get rid of that and make this suddenly simplified, the trick, you have these negative exponents, multiply by 1, basically to kill off this exponent. This will get rid of all the square roots in the top. This is a nice way to start cleaning these up. So we didn't clean them up in chapter 2. If you get something like this, this is the process. What happens here? times this term. This times this is what?
1?
1. You have something to the 1/2 times something to the negative 1/2. That's y to the 0. What's y to the 0?
1.
1. Why did I choose what I did? Because you all the negative exponents on the top. So then what happens on this one? This is where more magic happens. This times this is what?
Just a 1 exponent?
It just comes to the power 1. That's convenient. So I no longer have a fractional power in the numerator. But then the price I pay is what? I now have this in the base. It didn't just go away, I just moved it to the base. Yeah.
Isn't there supposed to be a square? The x squared plus 1?
This,
Yeah, wasn't that squared in the previous step?
yes. Yep. Alright, so what happens in the top? This is now x cubed plus x minus 2x cubed plus 2x over all of this. So what do I get in the top? Negative x cubed plus 3x divided by this. Alright, I found my derivative. I can also factor. What would it be if I factor? I can get an x out. That would be left with 3 minus x squared over all of this. You all practice cleaning up the chapter 2, right? You didn't just like get the answer and be like, awesome, I'm moving on, this is great. So now what? I need to know critical numbers. So I need to know when is this equal to 0? When is it equal to 0?
When the top equals 0?
When the top's equal to 0? So I need what? X equals 0 or x squared equal to 3. So x is plus or minus square root of 3. What about n to 5? Main problem would be when x squared minus 1 is equal to 0, so x equal plus minus 1. I also can't take the square root of the negative, but what do you notice about that? That's the same issue I had before. So that kind of goes back to this x equals 0. Is this a critical number? Yeah.
But I thought x equals 0 is not in your
It's
domain.
not. So the fact that I have an x here, is this ever going to be a 0 here because of x? No, because I never plug in x equals 0 because it's not my domain. Right? If my function is undefined, f prime is also undefined there. The fact that we have a form, so this is always a weird one. You get your formula, you still want to think about your original domain. And really, what would happen, it's hidden. I have a square root in the bottom. If I plug in 0, this would be the square root of negative 1. I can't do that. So like x equals 0 never actually comes into play. Alright, so now I can draw a number line here. For f prime, there's negative 1 and 1. at these two numbers, my value does not exist, right? And then what are the other numbers that matter? Plus square root of 3, minus square root of 3. I plug those in, I get 0. Is that believable? Now what do I need to do? Plug in test values. Yeah. So I need a number between 1 and the square root of 3. What would actually be easy to plug in? For that? I can do something like square root of 2, yeah. Square root of 2 works, right? There's that part. What do I get if I plug that in? Positive square root of 2 times, all these are squared, so it actually works out nicely. 3 minus 2 divided by 2 plus 1 squared times 2 minus 1, 1/2. Is that going to be positive or negative? Everything in the bottom is a positive number. So I get everything at the bottom is a positive number. So when I multiply and divide, it stays positive. So this is greater than 0, and put a plus sign. What can I plug in bigger than root 3?
2.
Yes. Root 2. Numbers would get bigger if I could do that. So if I plug in this, you end up getting a negative. I'm phoning it in now because I'm looking at the time. Would that one work? Why would it be negative? This is positive, this is positive, this is positive. What happens here? If I plug in a big number, 3 minus that becomes negative. So anytime I start plugging in these big numbers like 2, if you have a calculator, you can plug it in, you can always write it out. But one thing I always look at is positive, negative. None of this matters, it's always positive because of the way my domain don't work. So really it's a positive times negative, I get negative. What happens if I plug in on the left side? Yeah.
But it's not going to care about that's negative because we're
Yeah.
squaring.
The only thing, I have all squares, so all these behave the same, right? Except for this x. Now when I plug in a negative number, this gives me a negative sign instead of a positive sign. So the only difference, say I plug in f prime of negative square root of 2, is that going to be the same sign or the opposite sign? All the factors are the same except that x part. What happens on the x part? Now it has a negative. Like this number here is negative now, but all the other numbers are the same. I could just plug it in as fashion. You end up getting the same thing with a negative sign. It would be the same answer but negative. Same with this one, if I plug in something like negative 2, it would be whatever this number is, but positive. And it's because this term gives me a plus or minus sign, whereas before I didn't have something like that. It was always a positive number. So this becomes a plus, this becomes a minus. All right, we have f and f prime. That's it. It's 2/3 of the work, but it's going to take a second to review of something that's awful. Any questions so far? Hey, what do you think is going to be on the test for this problem? That would be a one problem test. On tests, in quizzes, we will do things like, here's the number lines, draw a picture. Here's a function where it's increasing, decreasing, you have to do maybe one number line. We're not gonna make you do 12 number line, or, well, I should say 12, but all 3 number lines, all limits, all function values, everything, and then put it all together. That will be multiple problems, all worth partial credit. It's not gonna be something where you make a mistake in this part, now you can't do the rest of the problem. So, this is a case where on the exam or quiz, it won't be, here's your homework problem, here's the same problem, we changed it slightly. It'll be, here's a part of the problem, because that's all we have time to test for. And then we'll have different parts in different places. Right? So, unfortunately, for better or worse, it's not the same as just doing the homework, or it's not an exact homework problem on a blank sheet of paper. It's because some of these take too long, especially the graphing. Although the graphing one you'll have in your homework tonight is nowhere near as long as this. Alright, so I need a second derivative. The second derivative, so take the derivative of what we ended up with, x times 3 minus x squared. Alright, I want the derivative of this one. We've done this before class, no, I don't want to do it during class. So what is that? Take the bottom function, multiply by the derivative of the top. When I get the derivative of the top, what do I need to do?
Product.
Product rule. So, product rule will give me this.
Wait.
Would it be simpler to just?
Yeah, just use the just use.
Why would we do logarithmic? That would be.
Oh, wait, no. I was more gonna say, why not just use with the unfactored version of the top, so we can just do the power rule?
I like this discussion. They didn't teach y'all to be intelligent. No, I'm in logarithmic. I've done it this way, and it's, we'll say, fun.
So why not just make it easier on ourselves?
Alright, I like this one. Y is equal to f prime. So y is equal to this. This is like a review for your final exam. Alright? This is we're reviewing all of chapters 1 through 3 for your final right now. Again, not in your homework, but this is something you actually can do at this point. I mean, you could have just done your computer a long time ago, I guess. I like the idea of logarithmic. Natural log of y is natural log of x plus natural log of 3 minus x squared minus 2 times natural log of x squared plus 1 minus 1/2 natural log of x squared minus 1. Y'all don't want to see every step. So 1 over y dy dx is 1 over x plus 1 over 3 minus x squared times negative 2x minus 2 times 1 over x squared plus 1 times 2x minus 1 over 2 times x squared minus 1 times 2x. What's less work? Huh. I've been teaching that for years. Why would I never use it? There is one flaw in this approach. Anybody know what the flaw is yet? square the curriculum. Can I just say, hey, when x is equal to 0? No, because something like this might not be 0. What do you have to do?
You can just make them have common
You have
denominators.
to do a common denominator. I still need this to be one fraction.
Actually, 2 of them already have common
Yeah,
denominators.
it's not as bad as it looks. So what's my common denominator? This. And then what? Oh yeah, you want to do times x plus. No, I'm common denominator. I couldn't quite do anything nicer because of this part. So what happens here? I get 1 times a bunch of these. I think that you were wrong to say let's do logarithmic. That would be the worst thing I've ever heard. Slow down the train. I'm going.
No, you
Doing the product rule.
You should have done what I said, where basically you take the unfactored version of the top instead of doing the product rule. That's what I said to do.
I don't like that common base. The derivative was a lot easier. It's the critical number part that always comes back to bite you. Setting it equal to 0 always comes back to bite you. I can tell you things, but we don't really know it. So, y dx equals to y times something. I actually did all this. I did it this way, and it was actually, I should say this, but in some ways it was easier. And why was it easier? Treating this like homework. In homework, you do different things, you have a good idea, and then anything you do in math, you can have a great idea, and then suddenly it gets awful. This technically isn't too bad, because it would quickly collapse after you multiply it out. Kind of like when you did limit definition of a derivative. When you expanded the top, so when you combine everything, something 2 boards long becomes this. That's exactly what would happen here. This would almost all cancel out quickly once you multiply it out. But you have to multiply it out first. We never tell you combining fractions is hard. It gets much bigger, much faster. Right? So, looking at time, can't quite do all this. What do you get? This is still going to be does not exist. This is still going to be does not exist. You minus double prime. Now I say don't just look at the back of the book and write the answer. That's because you're not allowed to. I'm allowed to. There's going to be some number right here that's bigger than square root of 3, we'll call it C, where I get 0. You're going to do all this work, and there's going to be one number that you get as a critical number on the right and the left. Yep.
And then also afterwards, you have to multiply the original function by that.
Yeah, that part's not bad. Multiplying y back over y was just this. So that one's not bad. That doesn't really add much. Compared to everything else we're doing, that doesn't add much. When you do all this, concave down, concave up. Concave up, concave down. And you'll feel very accomplished if you get really bored and decide to find what C is. Or you won't because it'll be a lot of work. And you already know the answer. So, we do all that. Do all that. And we're going to have this looking at us. We said these are zeros. So I need to combine number line. What's my combined number line look like? We said it's always positive. And because I know the answer is bigger than root 3. I can say I know there is an answer. It's bigger than root 3. What happens? We're always positive. This is what's depressing. You still only need 3 numbers. Technically 6 numbers, but everything that happens over here in reverse. If you do all this work, this whole problem comes down to 6 numbers that you plug in. The problem is knowing exactly which x value to plug in, which could be hard to find. That's what's kind of crazy about these ideas. Things that look awful and take forever, all it is to find that one x value. And then the rest of the problem is just plugging that one number. So when you do this, you end up with what? Go back to my number line for f prime. What is that, plus minus?